looking at right around that 2,400 pound mark. So we'll run this out to 10,000 cycles, get a photo of the part, see how much longer it lasts, keep running it in 10,000 cycle increments until it fails.
Generation 1 to Generation 2 was a huge leap forward for Perry parts. Our original generation material and product was made from 3D printing filament, and this is good for a lot of products. However, we identified a few areas for improvement. 3D printed filament is oftentimes not intended for use in extremely harsh and strenuous circumstances, which is what these products are susceptible to. In order to work with the utmost in materials, we retrofitted our machines so that way we could use injection molding pellets directly. And so instead of 3D printing from filament, we now 3D print directly from injection molding polymer or small granules like pellets. Using those pellets, it opens up a huge number of opportunities for material selection. So the next step was, now that we have this ability to print from basically anything, what do we print with? For that, we worked with our friends over at Covestro, which is a US-based polymer supplier and manufacturer. Working with their applications engineers, we showed them the product that we make, as well as the use cases for the product. And we tested out a couple of different options and settled on a material, a TPU with them, that is hydrolytically stabilized and is super durable. It's intended for molding bumpers and other products similar to what we make. One of the key features of this new material is that it's hydrolytically stabilized. When polymers are exposed to high temperatures and high humidity, they can be more susceptible to degrading in mechanical properties. By being stabilized like this, our product is more durable in extreme circumstances like high temperature, like running in the desert, or in high humidity circumstances, wheeling near the beach, being in a humid space. Regarding this test, so this test was designed to compress the part to the most load that it would see under normal use cases. When you bottom out your suspension takes a lot of that load and passes a little bit of that load onto the bump stop. In this case, we're testing out to between 2,100 and 2,400 pounds of force. That's nearly 1,000 pounds higher than any of our competitors have ever tested their product, and here we're doing it 100,000 times. One of the key features of using additive manufacturing is that when coupled with rapid abuse testing like this, we're able to identify where the weak points are in the product and locally reinforce the product. So for instance, if we saw a kink or some other sort of deformation in the part, we can locally go in and reinforce the part in that region so that way the load is spread out better across the entire product. That's one of the key features of using additive, is not only the ability to iterate quickly, but also the ability to locally design features, which you otherwise wouldn't be able to do using injection molding or other molding techniques. All right, we're slowing down the time lapse here so you can get a brief check-in at the 50,000 cycle mark. Speeding back up now, getting back to that 300x speed. So one of the things you'll notice with this video feed is it looks like the part is being cycled very slowly. And the reason for that is the alignment between the frame rate and the number of shots in the time lapse as they were taken. Just a quick reminder, the test speed is 1 cycle per second, as you can see in all the live feeds, as well as when the time lapse slows down. Roomba knocked over the camera there for a second. But the test is run at 1 cycle per second, so the time is there at the bottom for you to be able to reference in order to know how many cycles the part has been put through. The intent behind running this test prior to doing any additional testing or comparative testing between our product and some other products on the market was mainly to start by building trust in people that 3D printing is a viable process for making real functional products. So start there and then build off of it with performance and demonstrating effectiveness of the product. Because at the end of the day, if it performs really well but it doesn't last, a lot of people aren't going to be interested in it regardless. So we're starting out with this longevity testing, and then we have some additional testing coming up regarding dynamic rebound and compression, which we're sending out for a third party to analyze as well to ensure that there's no bias being added to the messaging there. But that information will be coming out in the next couple of weeks. One of the other really awesome things about using additive manufacturing for making products like this is that not only can you tune the size and shape of it, but you can also tune the spring rate, the rebound, the compression of every product. By modulating the shape and structure of the internal structure, the parts can be made stiffer, softer, more progressive, less progressive. But the really cool thing is by modulating the amount of airflow coming out of the product, you can also tune the amount of rebound and compression damping. So that adds a whole nother dimension to the way that these things work. By controlling that fluid, in the same way that a shock controls oil, we're controlling air. By controlling that fluid on the way in and out of the bump stop, you're able to create basically a dead blow effect, where if you ever used a dead blow hammer and you hit something and it doesn't bounce back at you, imagine using a rubber hammer and you hit something and it bounces right back at your face. That is not what you want, because all of that energy is then going back into your suspension. Your shock has to then handle that with its rebound damping. If you can allow your bump stop to eliminate that and pull that energy out of the system from the get-go before you even have it go back into the shock, then you end up with a more stabilized, a more controlled suspension setup. And that's what we're aiming to do here. There's a fine balance between all of these things. You can go too far into rebound, too stiff, too progressive. Interestingly enough, if your product is too progressive, it feels harsh because you don't actually feel that ramp up and you just end up feeling the peak of the impact. So all of these things are things that we take into account. And the really awesome part is that with customers' feedback, we can then go back, tweak things, and tune them to make the absolute best product possible. And that is our goal and our mission. So we're getting really close to 100,000 cycles here. I want to thank you for spending the time to sit through this and listening to me talk about the product. We've slowed the video feed back down to 15x, so this is one frame every half second, so 2 frames per second. You can see how many cycles the part's going through. And if there's anything that you have questions about regarding this testing methodology, the product, or anything else for that matter, please reach out, patrick@perryparts.com, or you can use their contact form on our website. Really appreciate you taking the time and having the interest in Perry Parts, and we'll wrap it up right here. Thank you. All right, here we are, 100,000 cycles later. Part's still looking really solid, no separation of layers on the part, and we're still developing in excess of 2,100 pounds of under compression. Thanks for watching.